Hello out there, welcome to this tutorial on area of square. In this video, we'll be looking at how to apply the formula for calculating area of square to calculate area of given square with the length, as well as calculating the length given the area. So we start with the diagram of a square. The dash on all the sides of the square indicates that all the sides are equal, and as such this is a square. We create grids within the square so that each of these is 1 square centimeter. So that to calculate the area now, we are looking at how many square centimeters are there in the square. So we count 1, 2, 3, 4, 5, 6. This is 6 plus 6, 12, plus 6, 18, plus 6, 24, plus 6, 30, and plus 6 gives 36. So we have 36 square centimeters, which represent the area of this square. Alternatively, we can calculate the area from the length. We told you this is the length, this is the length, since opposite sides are equal, or all the sides are equal. So we can come ahead now to calculate the area by counting the number of squares that make the length. 1, 2, 3, 4, 5, 6. So we have a 6, and the other length is also 6. We multiply to give us 36 square centimeters, which is also another way of calculating the area of this square. So that generally we can see that this is length times length. So we have the area now as length times the length. Length times length is also written as L squared. So the formula now we are going to be using is area equal to L squared. And also, assuming you are given the area and you are to calculate the length, it is then going to be square root of A. That is to say, the length is square root of the area. So these are the two formulae we are going to be using in this tutorial, either to calculate the area given the length or to calculate the length given the area. So we start with the first problem. Problem 1. Calculate the area of each of the squares below. So we have 3 squares. The first one is 7 centimeters, the second one is 10 centimeters, and the third one is 15 centimeters. So starting from the A, we are given the length to be equal to 7 centimeters. And we know the area is L squared. So that's going to give us 7 times 7. And 7 times 7 gives 49 square centimeters, which represent the area of the square whose side is 7 centimeters. So we go to B. For B, the length is 10 centimeters. And since our area is L squared, we're going to have the area as 10 squared, which is 10 times 10. And 10 times 10 is 100 square centimeters. And that's all for B. We then go to C. And the length is also given as 15 centimeters. Our area still remain L squared. That's going to give us 15 times 15, since the length is 15. 15 times 15 gives 225 squared centimeters, representing the area of a square whose length is 15 centimeters. And that's all for problem 1. We then go to problem 2. For problem 2, the length of a square is 9.3 centimeters. What is the area of the square? So in our solution, we are given the length to be 9.3 centimeters. Area is still L squared, and that's going to give us 9.3 times 9.3. 3. This is multiplication of decimal numbers. We have one decimal place here, one decimal place here, and we are going to remove the decimal point to ease our multiplication. Thereafter, we apply the point. So we have 93 times 93. 3 times 3 gives 9. 3 times 9 gives 27. And here 9 times 3 gives 27. We write 7 and carry 2. 9 times 9 gives 81, plus the 2 we are carrying gives 83. So we have the product here. We are going to add them. This is 9. 7 plus 7 gives 14. We carry 1 to this place. 2 plus 3 gives 5 plus 1, 6. And we have this 8 here. And we said since we have one decimal place here, one decimal place here, making a total of 2 decimal places. Therefore, the product is going to be 2 decimal places. So we count from the last digit, 1, 2, and place our point, giving us 86.49 as the area of the square whose length is 9.3 centimeters. And that's all for problem 2. We then go to problem 3. For problem 3, the area of a square field is 6,400 meters squared. How long is the side of the field? In this problem, we are given the area to be 6,400 squared meters, and the length is not given. We are calculating the length, and we know that the length is square root of the area. So therefore, we are going to have the length to be square root of 6,400. So we are going to find a better way of calculating the square root of large number like this. This 6,400 can be written as square root of 64 times 100, and square root of 64 is 8, square root of 100 is 10. So we find the product of 8 and 10 to give us 80, which means the square root of 6,400 is equal to 80, representing the length as 80 meters. So that's all for the length of the field. We then go to problem 4. The cost of tiling a square meter is $3. How much will it cost to tile a square floor of sides 5 meters? So in our solution, we have to calculate the area of the square floor first. Then we apply the cost appropriately. So we are given the length to be 5 meters, and we know our area is L squared. That's giving us 5 times 5. 5 times 5 gives 25, so that the area of the floor is 25 square meters. And we are told that a square meter is $3. So that is 1 square meter is equal to $3. Since we have 25 square meters, we are going to have 25 square meters to be 25 times $3. 25 times $3 gives $75. So that the cost of tiling the floor is $75. And that's all for problem 4, and this is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Until we come your way again, goodbye.